All right, we're going to talk about quadratic equations. All right, quadratic equations. These are kind of things that you should already know. It's a second degree polynomial equation. There's two solutions. Even though we say that there's one solution because it's a double root, there's actually two solutions. But we do say that there's one solution if it repeats. Your standard form is ax squared plus bx plus c equals 0. So in other words, it has to equal 0. Your zero product principle is if you have a times b equals 0, then a equals 0 or b equals 0. The graph is called a parabola, and the solution is or are where the parabola intersects the x-axis. So just here's an example. Here's where I have two distinct solutions. All right, there's many different ways of solving quadratics. We're going to look at one particular way of solving quadratics. And this first one we're going to look at is solving quadratics by factoring. So write the equation in standard form, which means it has to equal 0. You want to always keep your leading term positive. So make sure that your equation equals 0. Then factor completely. Start off with greatest common factor and then factor by the number of terms. Once you've factored completely, use your zero product property to each factor. So you set each factor equal to 0. Solve your mini equations. Check your solutions. You can always check your solutions and then put it in solution set form. All right, here I'm going to do a couple examples of solving by factoring. So the first thing I want to do is make sure that the equation is in standard form. So I have descending order of my exponents, but then this doesn't equal 0. So to make it equal 0, I'm going to go ahead and subtract 8 from both sides. So then I have 3x squared minus 2x minus 8 equals 0. Then my next step is to factor completely. So for me, when I factor completely, most of the time I'm going to use a guess and check method. Can you use the AC method? Always. So binomial times binomial equals 0. So my first term is 3x squared. The only factors of 3 are 3 and 1. So therefore, I know one term has to be 3x, and I know the other one has to be x. I go to my last term to figure out about my signs. Since this product right here is negative, I know that one has to be positive and one has to be negative. So negative, positive. And my factors of 8, the first factors of 8 that I think of are 4 and 2. So I'm going to go ahead here and place a 4 here and a 2 here. Now I'm just guessing, could I have placed the 4 over here? Absolutely, but this is when you use an educated guess. And I look at that I would have to multiply times this 3 times 4 and then a 2 times 1. And that difference isn't just a 2, and that's what I'm looking for, the difference to be 2. So now I'm going to, on the side, I'm going to check to make sure that this is my middle term. So I have 3x plus 2x, so I have 6x. And then I have minus 4 times x, so I have minus 4x. So therefore, I have a positive 2x. Is my middle term a positive 2? It's not. So since it's a negative 2, I know the only thing then I have to do is change my signs. So this one right here needs to be a plus, and this one right here needs to be a negative. All right, so now I'm just going to go ahead and I'm going to rewrite it. So I have 3x plus 4 times x minus 2 equals 0. So now I'm going to use my zero product principle, which means that I set each factor equal to 0. So I have 3x plus 4 equals 0, x minus 2 equals 0. and then I solve my mini equations. 3x equals negative 4, x equals negative 4 thirds, and then here I have x equals 2. So solve by factoring here, my solution set then looks like negative 4 thirds and 2. Remember that you can always check your solutions. All right, here's another one that I'm solving by factoring. So the first thing I'm going to look at here is it in standard form? Yes, this one is in standard form. It does equal 0. So then I'm going to look at factoring. Well, I have x squared and x, so the first thing I'm going to look for is greatest common factor. My greatest common factor here is 3x. Open my parentheses, write what's left. I have x plus 4 equals 0. Again, I have two factors. Once I have those two factors, then I can set each of my factors equal to 0. So then I have 3x equals 0, x plus 4 equals 0. Solving here, I get x equals 0, and then I get x equals negative 4. So writing it once again in my solution set, I have negative 4, 0. These are both x's. You can write them just as x equals 4, 0, comma, negative 4 also, but if you put it in parentheses, remember that I will take off points for that because it's not an ordered pair. It's two different x values. Now let's talk a little bit about the square root property. The square root property says if I have x squared equals c, so that's what I'm given, x squared equals c, then x equals plus minus the square root of c. So for example, if I said x squared equals 49, then what are my possible values for x? Well, x could be 7, right? Because 7, plugging it in there. But x could also be negative 7. So plugging in the negative and the 7, negative 7 times negative 7 is a positive 49. So if we have then maybe even something like x squared equals let's say 10, therefore x is equal to plus minus the square root of 10. When we are solving quadratics also, when you have no bx term, or when you already have something that's squared, and you have no x on the outside. So all you have in parentheses is something squared. So we're going to look at solving quadratics now using this square root property. So first thing you have to do is isolate whatever is being squared. That doesn't mean that you have to get rid of parentheses or anything like that. You just have to isolate whatever is being squared. Right? Then you make sure that you have only that x squared by itself. Take the square root of both sides, but remember it's plus minus the square root of the other side, the side without the x. All right, now we're going to solve by the square root property. So looking at the directions, right, it says ax squared equals c. That's because I need to get my quadratic term by itself. So the first thing that I'm going to do here then is I'm going to subtract 18 from both sides. So now I have 3x squared equals negative 18. Now I need to isolate what's being squared. So this x is being squared, so I have 3 times x squared, so I'm going to divide then both sides by 3. So now that I have x squared equals negative 6. All right, now that I have this right here, this whatever's right here that's being squared, I'm going to take the square root of both sides. Well, when I take the square root of both sides, don't forget your plus and minus. Also underneath here, I have a negative, so I need to make sure that I pull out and write it in standard form. So I have x is equal to plus minus I, and then I can't reduce the square root of 6, so square roots of 6. So here, plus minus I square roots of 6 is then my answer in set notation. All right, let's look at this other example that we have over here. All right, so even though I have parentheses and something squared, I don't have to worry about simplifying or anything like that here. I just need to isolate, once again, what's being squared. So this time I have 2 times this, what's in here. So now I'm going to then just divide both sides by 2. I can't distribute that in there. Don't forget, these parentheses, your squared comes first. So therefore I can't distribute and multiply before I square something. But we're doing it using our square root property. So now I have x plus 7 squared equals 8. Now I have what's being squared. I want to unsquare it. So how can I unsquare it? Well, I take the square root of both sides. Don't forget about your plus and minus. So now I have x plus 7 equals plus minus the square root of 8. When I have the square root of 8, I know my perfect square that's in there is 4, so I'm going to go ahead and say 2 square roots of 2. I don't really know why I put those there, so I'll just erase those. All right, so I went ahead and reduced my radical also. Now, I still haven't isolated my x yet. I still have to get my x then by itself. So therefore, I'm going to subtract 7 from both sides. So I get x is equal to negative 7 plus minus 2 square roots of 2. Then, of course, I always write it in set notation. So negative 7 plus minus 2 square roots of 2. And then close my set notation. All right, now we're going to visit another way of solving quadratics. We're going to solve by completing the square. So these directions here are the directions that you can use to solve, let's say, the standard form of a quadratic equation. When it's in standard forms, this is what you would do. So it says divide by a. That's just talking about if you have a coefficient on your x squared term. Move your constant over to the other side. So you want your x squared plus b divided by ax. Now, you might not have had to divide by a, so you might just have whatever that middle term is. But remember, you want that constant on the other side. When you move that constant over to the other side, you want to leave a space. You take the coefficient of your middle term, so you take your coefficient of your x term, divide it by 2. Then square it. When you square that value, you're taking a perfect square and you're adding it to both sides. A lot of times we remember to add it to the first side and we forget to add it to the other side. Your whole point for doing that is so that you can factor the perfect square trinomial. Factor that perfect square trinomial that you made. Then you use your square root property. Take the square root of both sides, which means you have the one side that's your plus and minus. Solve for your x. Once again, you can always check your solutions. Always check your solutions. It's when you're solving, if you have the time, check your solutions. So before we get into solving by completing the square, I just kind of wanted to do a couple examples here. It says determine the constant that should be added to the binomial so that it becomes a perfect square trinomial, then write and factor the trinomial. All right, so remember that right now we're not solving. This is not an equation. It doesn't equal 0 or anything like that. I want to make it a perfect square trinomial. In order to make it a perfect square trinomial, my middle term, I'm going to take just the coefficient. I'm not even going to worry about the sign, but I'm going to take 8 divided by 2 and then square it. So 8 divided by 2 is 4. 4 squared is then 16. Then I'm going to add 16 here. You're always adding. So my perfect square trinomial is then x squared minus 8x plus 16. That's my perfect square trinomial. Now I'm going to write it in factored form. This then equals x minus, what did I square to get here? 4 squared. Now let's look at our other example down here. We have another example here. So I'm going to do the same thing. I want to know what's going to make this a perfect square trinomial. It's always what the constant is that you're going to add. So what constant am I going to add when I'm take the coefficient of my middle term? So I have 14 divided by 2 and then square it. So 14 divided by 2 is 7. 7 squared is then 49. So 49 is my constant, so therefore my perfect square trinomial is x squared plus 14x plus 49. Now I'm going to write this one also in factored form, which equals x, because that's my first term, and then my sign here is plus, and then what did I square? 7 and squared. Alright, so here's an example of solving by completing the square. So I'm going to go through the steps. Number 1, it says divide by a. That's just you want to make sure that their coefficient in front of your x squared term is 1. It says move the constant over to the other side. So here's your quadratic term, here's your linear term, and then here's your constant. So I need to move that over to the other side, so I know I'm going to go ahead and add 11 to both sides. So now I have x squared minus 6x, I'm going to leave a space, equals 11. Now, solving by completing the square, this is now where we're going to make the left side over here a perfect square trinomial. So we're going to do what we just did. We're going to take that coefficient of that middle term, 6, divide it by 2, and then square it. So 6 divided by 2, 3. 3 squared is 9. So I'm going to add that 9 to this side over here, which means once I add it over on this side, since it's an equation, I have to also add it to the other side. Don't forget to add it to the other side. Now my whole point for making this into a perfect square trinomial is so that I can write it as a binomial squared. My first term is x, my sign is minus, what did I square? 3, and then equals. Make sure you simplify over on this side over here. What it doesn't tell you is that you have to turn around and now you're going to use your square root property. Your square root property, right here I have something squared. What do I want to do? Unsquare it. So I'm going to take the square root of both sides. When you take the square root of both sides, don't forget about your plus and minus. So now I have x minus 3 equals plus minus. Don't forget to reduce your radical. So I have 2 square roots of 5. Now I still have to solve for my x. So therefore I'm going to add 3 to both sides. So I have x is equal to 3 plus minus 2 square roots of 5. And here it is in my set notation. The quadratic formula is another way to solve quadratic equations. You have to know the quadratic formula. Okay, so here, first of all, we have our quadratic equation in standard form. Once you have it in standard form, then you can, know what your x is, know what your b is, and know what your c is. But your quadratic formula, x is equal to the opposite of b plus minus the square root b squared minus 4ac, all divided by 2a. A lot of times we forget that it's all divided by 2a. I see that happen a lot. People just want to divide whatever's under the square root by the 2a. It's all divided by 2a. You have to know this for the test. You're not going to be given the quadratic formula. You have to know it. All right, so now we're going to go through an example. Just make sure that the equation is in standard form. Label your A, B, and C. Plug your values into your formula, your quadratic formula, and then you simplify. Make sure that you simplify all the way. All right, here's an example where we're going to solve the equation by using the quadratic formula. So first thing we have to do is make sure that the equation is in standard form. So I have descending order, and then it's supposed to equal 0. It doesn't equal 0 right now, so I'm going to go ahead and subtract 2 from both sides. So now I have 5x squared plus x minus 2 equals 0. So now that it's in standard form, I'm just going to go ahead and label A, B, and C. So A equals, B equals, and C equals. So I can see A is 5, B is 1, and C is negative 2. If you don't know your quadratic formula, then of course you should write your quadratic formula. I'm going to go right into plugging it in. So I have x is equal to negative b, so negative 1, plus minus the square root b squared, which is 1 minus 4 times 5 times negative 2, all divided by 2 times a, which is 5. So now I have x is equal to negative 1 plus minus the square root. So here I have 20, 41, 41 divided by 10. So next thing I look at is, can I simplify my radical? Are there any perfect squares in that radical? Nope, there are no perfect squares in that radical. Do I have any common factors between this term, my coefficient of my radical, and then my denominator? Nope, they have nothing in common. So therefore, that's in my simplified form. Can I separate my fraction? Absolutely, you can separate your fraction. But I'm just going to go ahead and say negative 1 plus minus the square root of 41 all divided by 10. Don't forget to make sure that your division is all the way over that negative 1 also, or all the way under. The last thing that we want to talk about in this section is the discriminant. The discriminant is simply what is underneath the radical. It doesn't include the square root, it's only what's underneath the square root. So it's b squared minus 4ac is your discriminant. Now, it tells you about your solutions. If your discriminant is greater than 0, then you're going to have two distinct real solutions. That means two different or not equal real solutions. If your b squared minus 4ac equals 0, so your discriminant equals 0, then you have one solution. We talked about it before that there's two solutions. That's because your two solutions repeat, so it actually is one solution. When we write our solution in set notation, we only write it with one. The other thing that we have is if it's less than 0, right? If it's less than 0 and it's underneath the square root, then it means that they're not real numbers. You have that I in there, so therefore you have two distinct imaginary solutions, which just once again means two different imaginary solutions. All right, compute the discriminant. The discriminant, remember, is just b squared minus 4ac. First thing I need to do is make sure that it's in standard form. In this case, is this one in standard form? Yes, it's in standard form. So now I'm going to go ahead and compute my discriminant. Well, I'm going to label my A, B, and C first. So A equals 3, B equals -5, and C equals 4. So now I'm just going to go ahead and plug it into b squared minus 4ac. So b squared, it's -5, but anytime you square something, it's always going to be positive. So therefore I have 25 minus 4 times 3 times 4. So then simplifying that, I get -23. So therefore -23 is my discriminant. That's, remember, what's underneath your radical. The radical is not part of the discriminant, it's just what's underneath your radical. So my discriminant is -23. But since there is a negative that is underneath my radical, then looking at my notes, it says if b squared minus 4ac is less than 0, then there are two distinct, which just means different, imaginary solutions.